the situation described, several factors could contribute to a nail heating up and potentially causing a fire when in contact with an energized metal shell. Firstly, induction is a possibility. If the triplex cables carrying a significant amount of current ran parallel to the metal shell, they could induce a current within the shell. The magnetic field generated by these current-carrying cables can induce eddy currents in nearby metal surfaces, leading to heat generation. Secondly, a ground fault could be the culprit. If a fault occurred within the triplex cables, current could leak into the metal shell through a ground path. The resulting current flow through the shell could cause the nail, which is in contact with the shell, to heat up due to resistance. Other possible causes should also be considered. One possibility is faulty wiring. Poor electrical connections or damaged wiring inside the wall could have caused arcing or overheating, which in turn ignited the siding. Another potential cause is friction. If the metal shell was rubbing against the nail, the friction could have created enough heat to ignite the siding. Static discharge is yet another possibility. Static electricity buildup in the metal shell could have discharged through the nail, causing a brief spark that ignited the siding. Finally, sunlight reflection could play a role. If the aluminum siding was highly reflective, it could have focused sunlight onto the nail, causing it to heat up and eventually ignite the siding. To mitigate these risks, several recommendations should be followed. One should trace the path of the triplex cables to ensure they are not damaged or cutting into the metal shell. Use conduits or other protective measures to prevent the cables from coming into contact with the metal shell. Inspect the electrical system within the wall for any potential faults or loose connections. Investigate the possibility of friction or static discharge as contributing factors. And consider using non-flammable materials for future siding installations. Let's delve deeper into the specifics of each potential cause and the corresponding recommendations. Considering induction is essential to understand how alternating current flowing through a conductor generates a magnetic field. This magnetic field can induce a voltage in any nearby conductor, including the metal shell of the building. The magnitude of the induced voltage depends on several factors, including the current in the triplex cables, the distance between the cables and the shell, and the length of the parallel run. If the induced voltage is high enough, it can drive a significant current through the metal shell, leading to heating due to the shell's inherent resistance. To address this, ensure that the triplex cables are not run parallel to the metal shell for extended distances. If parallel runs are unavoidable, increase the separation between the cables and the shell. Shielding the cables can also reduce the magnetic field and minimize induction. This can involve encasing the cables in grounded metal conduit. Focusing on ground faults, it is imperative that the insulation on the triplex cables degrades or is damaged. A fault can occur where the current strays from its intended path and flows through unintended conductors, such as the metal shell. This stray current can then flow through the nail, causing it to heat up due to its resistance. Ground faults can be caused by a variety of factors, including physical damage to the cable insulation, moisture ingress, or improper installation. To prevent ground faults, ensure that the triplex cables are installed according to code and that they are adequately protected from physical damage and moisture. Regularly inspect the cables for signs of wear and tear, and replace them if necessary. Ground fault circuit interrupters, also known as GFCIs, can detect even small ground faults and quickly interrupt the circuit, preventing the flow of current through the metal shell and reducing the risk of fire. Shifting our focus to faulty wiring within the wall, poor connections or damaged wiring can create points of high resistance, leading to overheating and arcing. Arcing is a particularly dangerous phenomenon where electricity jumps across a gap in the wiring, creating intense heat and sparks that can easily ignite nearby combustible materials. Faulty wiring can be caused by improper installation, loose connections, corrosion, or physical damage. To mitigate the risk of faulty wiring, ensure that all electrical connections are made properly and that wiring is adequately protected from physical damage. Regularly inspect the wiring for signs of wear and tear, and replace it if necessary. Arc fault circuit interrupters, also known as FCIs, can detect arcing conditions and quickly interrupt the circuit, preventing a fire from starting. Considering friction as a potential cause, If the metal shell is rubbing against the nail, the continuous friction can generate heat. This is especially true if the surfaces are rough or if there is significant pressure between them. The heat generated by friction can build up over time and eventually ignite the siding, particularly if the siding is made of a combustible material. To prevent friction-related heating, ensure that there is no direct contact between the metal shell and the nail. Use non-conductive spacers or insulators to separate the two surfaces. Lubricating the surfaces can also reduce friction, but be sure to use a lubricant that is compatible with the materials involved and that will not attract dust or debris. Static discharge is another factor to consider. Static electricity can build up on the surface of the metal shell due to various factors such as friction with other materials or exposure to an electrostatic field. When the static electricity discharges through the nail, it can create a spark that ignites the siding. Static discharge is more likely to occur in dry conditions, where the air is less conductive and allows static charges to build up more easily. To prevent static discharge, ground the metal shell to provide a path for the static electricity to dissipate safely. You can also use anti-static sprays or coatings to reduce the buildup of static charges on the surface of the shell. Another less probable, yet possible, cause is sunlight reflection. If the aluminum siding is highly reflective, it can focus sunlight onto a small area, such as the nail. This concentrated sunlight can generate significant heat, enough to ignite the siding, especially if the siding is dark-colored or easily combustible. To mitigate this risk, consider using siding materials that are less reflective. You can also plant trees or install awnings to provide shade and reduce the amount of sunlight that reaches the siding. In addition to the above recommendations, it's important to consider the overall electrical safety of the building. Ensure that the electrical system is properly grounded and that all electrical components are installed according to code. Regularly inspect the electrical system for any signs of wear and tear, and address any issues promptly. Educate employees about electrical safety and the potential hazards associated with working around electrical equipment. By taking these precautions, you can significantly reduce the risk of electrical fires and ensure the safety of the building and its occupants. Furthermore, consider the specific properties of the materials used in the construction of the building. Aluminum siding, while generally non-combustible, can still contribute to a fire if it is in close proximity to combustible materials. Ensure that there is adequate fire stopping between the siding and any combustible materials within the wall cavity. Fire-stopping materials can help to prevent the spread of fire by creating a barrier that blocks the flow of hot gases and flames. Also, consider using fire-retardant treated wood for any wood framing within the wall cavity. Fire-retardant treated wood is less likely to ignite and burn, which can help to slow the spread of fire. Finally, ensure that the building has a working smoke detection system. Smoke detectors can provide early warning of a fire, giving occupants time to evacuate safely. Test the smoke detectors regularly to ensure that they are functioning properly and replace the batteries as needed. As a final thought, it is important to engage a qualified electrician to inspect the entire electrical system and make recommendations for any necessary repairs or upgrades. A qualified electrician will have the knowledge and experience to identify potential hazards and to ensure that the electrical system is safe and compliant with all applicable codes and regulations. In addition to the immediate concerns related to the nail heating incident, it is also important to consider the long-term implications for the building's electrical system. The fact that the triplex cables were run underground without conduit raises concerns about the overall quality of the installation. Underground cables should always be protected by conduit to prevent damage from moisture, soil conditions, and physical impact. The lack of conduit could lead to future problems such as cable deterioration, ground faults, and electrical shorts. It is recommended that the entire underground cable run be inspected and that conduit be installed to protect the cables. Furthermore, the fact that the metal shell of the building was cutting into the triplex cables is a serious safety hazard. This could lead to a direct short, which could cause a fire or electrocution. The cables should be rerouted so that they are no longer in contact with the metal shell. In conclusion, the nail heating incident is a symptom of underlying problems with the building's electrical system. A thorough inspection and necessary repairs are essential to ensure the safety of the building and its occupants.